to do today? We're in chapter 2. Congratulations. You survived all the way to chapter 2. All right? You survived back there, Derek?
No, I can't breathe.
Can't breathe? Okay. All right. What I want you guys to do is we're going to talk about this word right here called a relation. All right? Basically, a relation is any, I'm going to put any set or sets of ordered pairs. Okay? So basically, anything you put on a grid is going to be considered a relation. So basically, when I say ordered pair, think of an x-coordinate and a y-coordinate. Okay? We're going to be going over the vocabulary that's on your paper in that top right-hand corner. We're not going to be going over it in order, but just as we go through the vocabulary, we'll be defining different things. All right? Now, a relation can be a function, but not all functions. All functions are relations, but not all relations are functions. Yeah, it's like, well, yeah, it's like squares and rectangles. All squares are rectangles, but not all rectangles are squares. All right, so here's what I want you guys to write. Write the word function. Spell it correctly. All right? And basically say a set of ordered pairs. There's lots of ways to define this, but the basic concept is a set of ordered pairs where each x value corresponds with exactly keyword 1 y value. So each x has 1 y that it goes with. Now, we're going to draw a little picture here, all right? And if you can draw it with me. All right? We're going to make a little machine here, all right? We're going to call this the function machine, all right? We're going to make like a little machine. All right? Hold on, let me finish drawing the machine here. You want to fast forward through this if you're watching this video, I totally understand. Alright? Alright, so right here, we're going to call this machine the function machine. Alright? So f of x, when I say f of x, I'm referring to a function. Alright? And in order for this function machine to work, you've got to plug in x value. So you take any x value, and that x value goes into the machine. The function computes it. Right? Who can make a good computing sound? Yeah, nobody wants to, right? Like, yeah, you're recording this. Alright? So this computes something, and then out of this function machine spits out a y value. So when you plug in an x value, if you call this the x value, call it the input. When you plug something in, then it's going to have an output. It's only going to have one output. So we're going to make a function that some of you are very, very, very familiar with, right? Being that you're a high school student, all right? We're going to call this the minimum wage function. So, now this is a function, minimum wage. It's a very, very sad function, but it's a function nonetheless. All right? So, if I say, what's the minimum wage function? I'm going to say f of x equals 7.25x. We'll say for the state of Texas. Obviously, different places have different minimum wages. Like if you go to Seattle, I think it's $50. $8. Oh, that's just too bad. All right? So, by the way, what do our x values represent in this sad function for the minimum wage? What do you think? Hours. That's right, hours. Good. Hours. And what does f of x, also known as our y values, represent? Pay. So right now, I'm giving you an opportunity to represent what is a function. This is something that works. Sadly Now this is, by the way, this is before taxes, all right? And then taking all that wonderful stuff out of your paycheck. This is, we call this gross pay, all right? It's not what you actually get. What do we call that pay? It's an N. Net pay, all right? 2 hours, you get a whopping $14.50. 3 hours, you're all the way up to a $21.75. All right? And so on and so forth, right? So right here, this is a function because each hour you work, you get one output. So each input has one output. This right here is called the minimum wage function. It works. Why? Because each x has one y. Now let me give you an example of not a function. So we're going to go over here. So right here, this is going to be an example in your journal. Not a function. But I'm going to make an x and a y table and help you guys see the difference. So right now, so far so good? Would this be a function? So far so good, right? Each x has one y, all right? But we really don't know yet because we only have one ordered pair. So that's just a relation. But then I go 1, 725, yes. 2, 1450, yes. 2, 10. Something should go off in your head like something does not look right, Mr. Demude. Because right now, it looks like you have 2 of the same x values, but you have what? 2 different y values. All right, so these are different. So when you have the same x value plugged into something, and you have 2 different y values, that lets you know that this right here is definitely now not a function. And your explanation would be because each x value can only have one y value. Okay? So you can see this in a lot of ways. This is in a table. Okay? We're going to do it in a map. We're going to do it in a graph. So you guys know how to identify which one's a function, which one's not a function. Okay? So the next thing I want us to do is we need to talk about this concept called mapping. Okay? We're going to talk about mapping. So in your journal, talk about mapping. We are going to map this function. This is a function y equals x squared, or you could say f of x equals x squared. This is function notation. So right here, everybody, when you see f of x, that's referring to function notation. Is that one of your vocabulary words? It is? Okay. So when it says function notation, you're dealing with f of x, or g of x, or h of x. All right? So we're going to have a map, and the first thing we're going to do is we're going to do what you're used to seeing, which is a table, and then we're going to map the information. The numbers you're going to use is -2, -1, 0, 1, and 2. If you need to pause me, please pause me so you can catch up. I'm pausing here. All right, what we're going to do is we're going to fill this table out. So if I say -2, when you plug that in, what's -2 times -2, Garrett? 4. That's right, because a negative times a negative is a positive. All right, what's -1 times -1? 1. Correct. All right. Now, we all know what 0 times 0 is. That's just 0. And we all know what 1 times 1 is. That's 1. And then 2 times 2 is 4. But you guys notice something here? Do you see how we have kind of repeating y values? That's okay. That's all right. So we're going to map this. Here's what I want you to do. Put x here and put a big old oval. Put f of x right here. Put another oval. All right? In your x, basically, in the map of all of your x values, put -2, -1, 0, 1, and 2. But in f of x, which is talking about the y values, only write 0, 1, and 4. You don't have to, in math, you don't have to keep writing the same number over and over and over again. Okay, so let me explain to you how this works. Yeah, for a math class. Here's why. Now in a table, this is your table. A lot easier to read. But when you see something in a map, ask yourself this question. What does -2 lead me to? -2, when I plug it in, leads me to a 4. So you put an arrow going to the 4. Okay? -1 led me to a 1. 0 leads me to 0, 1 leads me to 1, and 2 also leads me to a 4. So when you're doing a math, when you see arrows being drawn, it's telling you that this number leads you, when you plug in this number, it leads you to a 4. And you can kind of see it's okay if the x values end up having the same y value. But every single time I plug in a -2 into this equation, what are you going to get every single time? You're going to get a 4. So, here's what I want you to write underneath it. Each x value still has only one y value. So it's okay. Each x still has only one. So this is a map. This is a map of a function. All right? It's a little bit more difficult map. Let me show you a really, really, really easy map. Sometimes they're really easy. Like this is totally going to be a function. Like if I said 0, 1, 2, and I said -5, 7, and 8, and I had lines going like this, that's pretty easy. Each x has one y. So it's a very easy map to read. Okay? So these are just two examples of maps that are functions. Now let me give you a map of something that is not a function. So right here I'm going to write not a function. So you guys know these are counterexamples or non-examples of functions. Okay? So we have x. Here's your x's. Here's your y values. So give me three numbers. 8, 5, 10, and 8. And give me two numbers. Two numbers. 11, 20. All right? Now, if I said 5 went with 11, and 10 went with 20, and 8 went with 20, that's okay. That would be a function. Here's what would not be a function. If 10, when you plug in a 10 and you got 20, and then you also said you got in 11. Because now, if you look at this right here, what am I saying? I'm saying this x value has not one y value, but it goes with two different y values. Okay? So, right here I'm going to write each x does not have just one y value. In fact, the 10 went to what? It went to an 11, and the 10 also went to a 20, which means you have the ordered pair, 10, 11, and you also have the ordered pair, 10, 20. So the inputs, notice the input was the same, but the outputs were different. The next thing I want you to do, turn your graphing calculator on, we're going to graph this equation. When I say this equation, I'm referring to y equals, and I want you to type in x squared, and I want you to graph it. Okay? So go ahead and graph it. We're going to talk about how to test if there are functions in graphs. That's what we're going to do the next video on.